Dear students, I am Mahesh Javalkar from Marathon Polytechnic, and today I am posting my 12th video on analog electronic circuits, in which I'll be telling about what is the feedback and what is the feedback with respect to amplifier, okay, and how many types of feedbacks are there. So let's go with the presentation. So the topic for this presentation will be feedback in amplifiers. Okay, so amplifiers are the main circuit, and then when you connect a output of the amplifier to the input, it will be called as feedback. Okay, so in the contents of this presentation, we will see what is a feedback, types of feedbacks, positive feedback, negative feedback, advantages of negative feedback, disadvantages of negative feedback. Okay, so here if you see the definition of what is a feedback, the process of sending part of the output signal of an amplifier back to the input of the amplifier is called as feedback. Now this you can show with diagrammatic also. Say this is your amplifier. This is your amplifier circuit. Okay. This is your amplifier. Now here you are going to give a input signal. This will be input. This will be output of the amplifier. If you connect this part of the output back to the input with a network, if you're connecting back to the input, then this network will be your feedback network. Okay, and this is how you are connecting the output back to the input. Now this output which you're connecting back to the input may help the input, that is plus, or may oppose the input, that is minus. Okay, so depending upon that you can have two different types of feedbacks. If it is helping the input, it is positive feedback. If it is opposing the input, then it is negative feedback. Okay, then again we'll see the same definition. Feedback amplifier is a device. Feedback amplifier, we are speaking about now amplifier with feedback. Okay, feedback amplifier is a device that is based on the principle of feedback, the process by which some part of fraction of output is combined with the input is known as feedback. This is what the definition we have seen earlier also for feedback. Okay. Then if you see the circuit of a amplifier with feedback, so here you can see this is the main input what you are giving here. So what you're giving here is the main input. Say for example, this input looks like this. Okay. Now it is going to pass through an amplifier circuit. Okay, amplifier circuit, and that amplifier circuit, say for example you're using a BGT amplifier, that amplifier circuit will amplify the input and give the output with a 180-degree phase difference. With a 180-degree phase difference like this, it will be amplified, but plus and minus, positive half cycles will become here minus and plus. Okay, so there is a amplified output. This output is amplified of amplified, and it is also having phase inversion. That is, there is a phase difference of 180-degree, between the input and output of an amplifier. Now that output of an amplifier, if you connect it here with a feedback network, this is a feedback network. Okay, this is a feedback network. If you're going to connect it to the input of the amplifier, okay, then it is called as feedback. Now here we have shown plus and minus sign. Plus means this feedback network will help the input, and minus means this feedback network which output it gives, it will oppose the input. Okay, so here depending on whether it is helping the input or opposing the input, we can have positive feedback and negative feedback. Okay, positive feedback means what happens whenever the output, which is 180-degree phase difference, comes here, and if the phase difference given by this feedback network is again 180-degree, okay, is again 180-degree, okay, then you will get here the signal like this, which will go with the input signal. Okay, so this both will be same in terms of phase. So this both the actual input here and this what is coming from the feedback will be in same phase, so it is positive feedback. Okay, similarly, if the inverted input, whatever you get at the output of the amplifier, when it is coming to the feedback, and if the feedback network gives 0 degree, it is not going to do any phase shift. Okay, then here the input to the amplifier will be out of phase. It will be like this, out of phase. Okay, minus plus. Okay, in that case, it is opposing the input. It is opposing the main input. Okay, the feedback output is opposing the main input, and that is will be called as a negative feedback. Okay, this is how your positive and negative feedback will come into picture. Now here we have shown a basic circuit, which is a main amplifier is there, and then the output of the amplifier is connected back to the input. It is called as feedback network. Okay, now feedback amplifier means what? Now, as we have seen in this diagram, a feedback amplifier generally consists of two parts. They are the amplifier and the feedback circuit. The feedback circuit usually consists of resistors. This is very clear from the circuit diagram also. Okay, then we'll go to see what are the types of feedbacks. As I have told you, when the feedback helps or goes along with the input in terms of phase, if the phase of both input and the feedback output is same, then it is called as positive feedback. If the feedback opposes the input, if the phase difference between the input and the feedback output is opposite, out of phase, 180-degree out of phase, then it is called as negative feedback amplifier. Okay, so feedbacks will be of two types. One is positive feedback and one is negative feedback. That only we have told here. Types of feedbacks, depending upon whether the feedback signal aids means helps, or opposes the input signal, there are two types of feedbacks. One is positive feedback and one is negative feedback. Okay, then we'll go to see what is positive feedback. So here we have shown a circuit of positive feedback. So here you are having your main input signal. Now this input signal, say if it is like this. Okay, so here you are having plus and minus. Okay, now that input signal will go to the amplifier. This is your amplifier circuit, and the output of the amplifier will be amplified version of the input. Okay, but with a phase reversal, So here you can see it will be having a phase reversal. Okay, so it will be minus plus. It will be amplified, but with 180-degree phase difference. With 180-degree phase difference. Okay. Now that will be taken. Okay, that will be taken and given to a feedback network. Now here you are having your feedback network. Feedback network. Okay, now this feedback network will see that whatever output of amplifier is there, that is again inverted into phase by another 180-degree. So it is inverting by another 180-degree. Okay, and then it is giving it back to the amplifier. Okay, that means this 180-degree on top done by the amplifier and this 180-degree done by the feedback network, both will be giving you 360-degree. 180 plus 180 will be 360-degree. So here output will be having 360-degree phase difference with the original input. That means again it will come back to look like this, only, plus minus. So the original input here on top, original input, this is the original input and this is the feedback input. Okay, now both are in same. These both, if you see, they are both in same phase. That means the feedback output, what you are going to get, it will help the original input because they are both in phase. That means here we have given the equation that the source voltage will be added with the feedback voltage. Okay, so this is will be called as positive feedback. Positive feedback. Here you have shown a plus sign and here you have shown a plus sign. Okay, so this is how your positive feedback will work. Now positive feedback will improve the gain. It will give a higher gain for the circuit, but it will compromise with stability. It will not give stability to the network because the gain will go on increasing. Okay, So there will be some disadvantages for this positive feedback, but positive feedback is one which you can use if you are building a oscillator circuit. Okay. Then if you see the signals phase, the original input, this is the original input. Okay, original input, and this is the output of the feedback circuit. This is the output of the feedback circuit, output of feedback. Okay, now both are in same phase. You can see both are in same phase. This is also plus minus, and this is also plus minus. So both are in same phase. That means the feedback is going to aid or help the input. It is in phase with the input. So it is positive feedback. Okay. Then if you see the note, whatever note you want to write on positive feedback, you can write like this. The feedback in which the feedback energy, that is either voltage or current, is in phase with the input signal and thus helps or aids it, is called as positive feedback. Both the input signal and the feedback signal introduces a phase shift of 180 degree, thus making the total phase shift as 360 degree, which is called as resultant phase shift around the loop, to be finally in phase with the input signal. It will be finally in phase with the input signal. It will help the input signal. Okay. So though the positive feedback increases the gain of the amplifier, it has disadvantages such as increasing distortion because the gain will go on increasing, and instability in the circuit. Okay. It is because of this disadvantages the positive feedback is not recommended for amplifiers, because for amplifiers you need stability. You need that the circuit should not vary even with the temperature. Okay. If the positive feedback is sufficiently large, it leads to oscillations by which oscillator circuits are formed. So here one thing you can remember, if you give a positive feedback to an amplifier, you can make an oscillator. If you give a negative feedback to an amplifier, you can construct an amplifier, proper amplifier. Okay. Then we'll go to see what do you mean by negative feedback. So again, here as we had explained the positive feedback, we can explain the negative feedback also. Okay. So here you can see the main input Vs, which is are given here. So this is your Vs. So Vs, say if it is looking like this is the wave, this is the input signal of the source Vs. This will be going as plus for your input. Okay, now that will go, it will be amplified, and in the amplification section, you will get a inverted amplified version of the input. Inverted amplified version of the input. So here you will get it. Okay, so if this was plus minus, if this was plus minus, plus minus, so here you will get minus plus. So here you will get minus plus. Okay, so this is amplified signal, amplified. Okay, and it is inverted in phase by 180 degree. Inverted in phase by 180 degree. Now that will be taken as a feedback. This will be your feedback. Okay, this was your amplifier on top. This was amplifier. Now this will be your feedback. Okay, and this feedback will give output Vf, but this feedback will not provide any phase difference. So the output here will be same like the output of amplifier. Okay, that means here if you're going to compare it with the main input, so here you can see this will be like this minus plus. So these both will be having 180 degree phase difference. 180 degree phase difference. Okay, what is coming from here from the feedback and what is the original? Both will be having 180 degree phase difference. That means the feedback input, whatever you are going to get here at this point, will oppose the original input. Okay, that therefore here we will put an equation after the are comparing that Vs minus Vf. Okay, so Vs was the source and Vf was the feedback. So it will oppose the source, and because it is opposing the source input, it is called as negative feedback. Okay, then if you see the signals here, So this was your original source signal. So this was plus minus, and the output of the feedback was minus plus, because after the output of amplifier, the feedback network has not provided any phase shift. So it has kept it as it is. So there is a 180-degree phase difference between the source and the feedback. So there is a 180-degree phase difference here. Okay. So that phase difference will say that it is a negative feedback. Okay. Now, if you want to write the note on negative feedback, you can write it like this. The feedback in which the feedback energy, that is either voltage or current, is out of phase with the input and thus opposes it, it is called as negative feedback. In negative feedback, the amplifier introduces a phase shift of 180-degree, that is basically into the circuit, while the feedback network is so designed that it produces no phase shift. So 0-degree phase shift is given by the feedback, or zero phase shift. Okay. Thus, the resultant feedback voltage Vf is 180-degree out of phase with the input signal Vn. Thus, gain of negative feedback amplifier is reduced. So this, because the feedback output is opposing the input, the gain of negative feedback amplifier is reduced. Okay. Now here you can see the signals. So here it is 180-degree out of phase. So this is 180-degree out of phase, what you have between your, this is plus minus, this is minus plus. So this is your original signal, this is the source signal, this is the original input, and this was the feedback output. Feedback output. Okay. So there is a phase difference of 180-degree, and therefore it is called as negative feedback. Okay. So negative feedback, it will reduces the gain, but there are many advantages of negative feedback, and they are very important for the circuit to be an amplifier. Okay. The first advantage is the negative feedback reduces noise. Okay. In spite of compromising with gain, it is controllably eliminating the noise. Okay. It has less frequency distortion because the gain will not go on unwantedly increasing. There will be no oscillations. So it has less frequency distortion. That means improved frequency response. For a particular range of frequency, the output will be stable. Okay, it will be having increased bandwidth. Okay, the range of frequency, useful frequency, will be more. It is will be having better stabilized voltage gain. Okay, voltage gain, even though it is less, it can be controlled properly. Okay, it has less harmonic distortion. There will be no fundamentals multiplication of the frequency. It has less amplitude distortion. Amplitude or the shape of the wave will not vary. It has less phase distortion. Phase distortion also will not take place. Input and output impedance can be modified as desired. Okay, as you want, you can modify input and output impedances. It has higher fidelity, that is, its reproduction of the waveform is same like the original. That is more linear operation. As the input varies, the output also varies linearly. Okay, so all these are very important advantages for an amplifier circuit. Okay, that is why negative feedback is used for an amplifier circuit. Okay. Then disadvantages of negative feedback. Now there are two disadvantages also. It increases output resistance in case of types current shunt and current series feedback amplifier. Okay, so we can have voltage shunt, voltage series, current shunt, current series feedback type of amplifiers where we concentrate either on voltage or current. Now in current shunt and current series feedback amplifiers, there can be increase in output resistance. This is one disadvantage. And obviously, the second disadvantage is, obviously we know it will reduce the gain, a reduction in gain. Okay. Thank you, students. So here I have told you about what is the feedback, and in that feedback, what is positive feedback and negative feedback. Okay. Thank you very much.